In this video, I'm just going to do a bunch of proofs from this famous Lewis textbook. Some of these maybe I'll do 2-column proofs, and some I'll do with the flow charts. So let's look at this first one. I want to show you how you sort of map out what you're going to do. And once you know the plan, actually writing it up is not so bad. So first of all, let's see what it is I'm trying to prove. I'm trying to prove that triangle ABC is congruent to ADC. So I'm going to, not a bad idea to get some colored pencils if you find that it helps you. So these triangles, first thing that I noticed just right away is that there's a shared side. So that's going to be one of the sides. Now I'm going to need more pieces. We're given that AB is congruent to AD. So now I have a second side. Now either this is going to become a side or a side angle side. Well, they're also giving us that angle 1 is congruent to angle 2. So I already know that the final reason is going to be side angle side. Remember, this angle 1 is the included angle as opposed to like angle B or C, which wouldn't be, because it's formed by the two sides. Well, now I write it up. So writing this thing up, it's not going to be a very long proof. Of course, the last thing is going to be that the two triangles are congruent. I can even write that in right now. And then we have some given. AB is congruent to AD. That's given. I like to put a little S here to say that that's one of my sides of, the three pieces. Angle 1 is congruent to angle 2. That was also given. That's a side. And this other one, we have to have three things in order to do the SAS. Oops, that one was an angle. Finally, AC is congruent to AC, reflexive. So this whole thing was 1, 2, 3, 4 steps, and that's the answer to number 1. Let's look at number 2. So there's only 2 triangles in this picture. Sometimes there's more and it gets a little harder to see, but ADB is this red triangle and CBD is this blue triangle. And first thing I'm noticing is the shared side, so that's going to be reflexive. They also tell us outright that AD is congruent to BC, so I have 2 sides now. And they tell us that angle 1 is congruent to angle 2. This is, angle 1 is not over there. Angle 1 is over here, which is good because this is your typical another side angle side situation. Yeah, this is a good place to do it. So we have our given. And that's a side and an angle. The other side is done by reflexive. And that's what I needed. So my 4th step is using side angle side postulate. I can conclude that triangle ADB is congruent to triangle CBD. And those are the first 2. For number 3, just to mix it up a little, I'll do this one as a flow chart. So the way the flow chart goes is there's going to be sort of 3 boxes for the 3 pieces: side angle side or angle side angle, and they're kind of come together to become. So here's question 3 on that sheet. Let's see what we have going on. There's obviously only 2 triangles in this picture. Sometimes there's more overlapping and things, but 2 triangles. And already I'm sure that this is going to be relevant, that BD is part of both. So besides the given, which is, I say step 1 and step 2, I'm not going to rewrite the given. Step 3, why not just get that in there already? BD is congruent to BD reflexive. And I can put like an S here to say that's one side. Now, maybe this is going to be SAS, maybe it's going to be ASA. Let's see. Step 4. So because BD is the bisector of angle ABC, that means these two angles are congruent. So I can actually say that. Angle ABC is congruent to angle CBD. See the order? Because A kind of corresponds with C in the other triangle. So if I call one, I shouldn't call it ABC though. I should have called it ABD and CBD. And the reason why is they told us it's an angle bisector, so it's definition of angle bisector. Now they also gave us another angle bisector. See, instead of calling it BD, they're calling it DB. So that means that these two angles are congruent. So angle CDB is congruent to angle ADB. Same reason. You could even put these together as the same step when they have the same reason. Well, looks like ASA to me. Triangle ABD and that was question number 3. Here's question number 4. Then I'll skip ahead to some of the harder ones. So there's 2 triangles in this picture, and those are the 2 we're being asked to prove congruent. Here's a shared side, so that's going to be in there. AC is congruent to AC. That's a side. Reflexive. I forgot over here to throw in the angle and the angle. What else do we have here? AC, so here's our given. So we're not given any congruences, so we have to create all 3 of them. AC bisects BAD, so that means this angle is congruent to that angle. Angle BAC is congruent to angle DAC, definition of angle bisector. So that's an angle. Now a decision has to be made. You see, I have a one side and one angle. This happens a lot. Get one side and one angle. And either I'm going for SAS, which would mean this side. Let me use the pointer. So if I'm doing SAS, I already have a side and an angle. So that would be this side with this side. Or maybe I'm going ASA, then it would be this angle with this angle. Which one? We'll find out by looking at the other given. AC is perpendicular to BD. So it turns out it's going to be an ASA. But I know it's coming, so I'm going to write it in. ABC is congruent to triangle ADC. But I notice how I only have angle side, so I have to also put in the angle. But that's going to actually take 2 steps, because I can't just say they're congruent, because my reason is going to be all right angles are congruent. And I am going to say that as the second to last step. Angle ACB. But the third to last step is saying angle ACB and angle ACD are right angles. I'll say definition of perpendicular. So we need step 3, 4, 5, 6, 7. Yeah, I could see how somebody might not want to write step 5, because it seems like you should be able to jump straight to saying that those angles are congruent, but you have to, perpendicular leads us to right angles, and right angles leads us to congruent. Okay, I'm going to skip ahead. Number 7, so they're asking us to prove that ABC, which overlaps a little bit with triangle DEF. So unlike the others, there's not like two sides that they share with each other. Now, fortunately, they tell us that AB is congruent to DE, so that's already one side. And angle B is congruent to E, that's already one angle. So now, either I'm going ASA, which would be this angle with this one, or I'm going SAS, which means this side from B to C would have to equal from F to E. Let's see which one they've given us information about. They've told us that BF is congruent to CE. So that is not a full side of the triangle. But that's okay, because we are going to be able to say that the full sides are congruent because they both have FC. So if this is step 1, step 2, step 3 for given, the fourth statement, I think I need, let's see how much room I need to say this. So we're going to say that FC is congruent to FC by reflexive, which now lets me put these together. I can't yet say BC equals FE, although eventually I am. In step 6, sorry, it is going to be step 5, because I already have that BF equals CE, and now I combine those two things together. And here's how I like you to write it. BF plus FC is congruent to CE plus FC, comma, or BC is congruent to EF. All that is addition property. Basically, I added step 3 and step 4 together. And now that I have it, that's also the missing side I needed. So my final reason is going to be SAS after all. So that one was a little bit more involved because it had the addition thing in it. This one's kind of interesting because there's several triangles that could be congruent in this picture. There are the little ones, which is what they're asking us to prove. But there's also sort of these medium-sized ones that have ABD, for instance, and AEC. Those potentially could be congruent, but they're not asking us to do that. Now, the funny thing about this is how much do they tell us already? Well, they tell us AB equals AE. That's good. That's already one of the 3 pieces needed. But now they don't give us another piece. They tell us angle 1 is congruent to angle 2, which is useful, but it's not actually one of the angles of those triangles. And they tell us BD is congruent to EC, which it's useful also. They tell us BD. But it's going to take a little bit of work. So, because 1 and 2 are congruent, this and this are also, because they're supplementary to 1 and 2. So that's going to be my first statement. Angle ABC is congruent to angle AED. And my reason is going to be supplements of congruent angles. And you could look back at a previous day where we just did that, not in the context of these 2-column triangle proofs. That's the angle I need. Now, as far as the side, BC and DE, we know that BD and CE are equal, and CD is here in the middle. So we can say CD is congruent to CD, reflexive. And then using subtraction, it's a little annoying, but I have to write BD. I'm using this with this. So BD minus CD is congruent to EC minus CD, comma, or BC is congruent to DE, which was the remaining side I needed, and that's why this thing is, so now I can say this piece is equal to that piece. So it's SAS. Okay, I'll finish out with this one. Now this has a lot of triangles in this picture that could be congruent. For instance, these two triangles could be congruent, or these two triangles could be congruent, or these two. So there's three pairs of triangles that could be congruent. They're asking us about ABC, which is sort of the left half here, and they're asking us about ACD. So that's what they're asking us to prove congruent. What's funny is that there's a reflexive thing going on here, but I don't think it's going to get used in this one. They tell us that AB is congruent to AD, so that's a side already. And they tell us that AC bisects BAD, which means those angles are congruent. That's why I'm going to start by saying angle BAC is congruent to angle DAC. And my reason's going to be definition of angle bisector. Now I have an angle equaling an angle and a side equaling a side. Now I could just use AC equals AC, reflexive, and be done, which is what I'd probably do. But I guess in this one, they're giving us this extra information, so let me show you how you could use it. If I just add these two things together, I could say angle 1 plus angle 3 is congruent to angle 2 plus angle 4, or angle ABC is congruent to angle ADC. Personally, I wouldn't do it this way. I would just use the reflexive, but it's possible if I really want to use all the given information, I would actually do this as ASA. But you totally could use SAS with the reflexive side. Okay, so those are some triangle proofs.